welcome to today's vibration research webinar. Today we'll be going over several common vibration test profiles. This will be a very broad topic. Talk about the basics on entering some profiles, a few tips and tricks, and hopefully a couple of other items that will make your job a little bit easier. So, Vibration Research Controller Company, we've been in business since 1995, so coming up on 30 years. Picture of John, President, CEO on the top left, along with Phil Van Baren. He is the Senior VP of Product Development. A couple of the friendly faces that you'll see around our headquarters here in Jenison, Michigan. Several other offices, so we have 5 international offices: China, Czech Republic, Germany, India, and the UK. So we are an international company with a presence all over the world. We are headquartered here on the west side of Michigan, and we have several employees throughout the U.S. as well as an extensive rep network. So wherever you may be located, we are always available and willing to help. Core values of ER as a company: collaboration, sales, engineering. We all work together to try get the best solutions for our customers, also developing the best software on the market today. Capable and competent. We have a lot of very intelligent people that work at VR. Accountable, responsible. We'll talk about support a little bit as we go through the presentation today. Strong and driven. We work hard, do the right thing, and also innovation. So core values, you'd see these if you're walking through our headquarters here in Jenison. We've got them on the walls all over the building here. VR also is known for innovating. So we have patented several software technologies or several capabilities. Starting with field data replication back in 1995, we will go through one of those tests and how you enter that. Next was Curtosion, 2005, FDS, fatigue damage spectrum, in 2010, IDOF 2015, and STAG, or sign tracking analysis and generation, in 2020. VR has a history of investing, innovating, always coming up with new technologies for vibration testing. Won't be talking about a lot of these today, but stay tuned. We will have something to add to this timeline, I'm sure, in the near future. So we're going to jump in. Today, as I mentioned, will just be, we'll call it a 30,000-foot view of entering test profiles. So if you've used our equipment, chances are you've had to enter some customized test profiles. We have examples of the more common test modes that we see, and I'll walk you through basically just the setup step. We're not going to go into the control loop parameters, really not a lot on the schedule level or anything like that. This is very, very broad. How do I enter a test profile? If you have any questions in addition, we'll have time for questions at the end, or as always, feel free to reach out on the phone, via email, whatever works best for you. First one we'll talk about is simply a sign test. So this is going to be a pretty basic sign test. If you are following along, feel free to open up Vibration View, enter the values in yourself. You're more than welcome to. If you'd like a copy of the slides at the end, put a comment in the comment section, and I'll be sure to follow up and send you a copy. So for Sine, there's a couple of required parameters. We've got frequency range, acceleration level, sweep rate, duration, control channel. Screenshot you see on the right, this will be similar to what we enter. We'll start in simple test mode. If you're someone who likes to work in simple test mode, great. We will have an example in our advanced test setup as well. This is a feature it's been here for a handful of years, but simple test versus advanced test. we can show you the difference, and feel free to use whatever you would like. Our first profile is going to be a sweep, so sine sweep from 5 Hertz up to 1,000 Hertz. There's a couple of steps here. We have a displacement limit of 1/4 inch, and then control on 1G. The 1/4 inch step, this generally comes in at the low frequency. So low frequency equals high displacement. And basically what this is doing is saying, okay, you don't have to have a shaker with 2 inches of stroke, 3 inches of stroke, or something like that to be able to run this profile. You're allowed to limit the stroke to 1/4 inch, and then at some point 1G and 1/4 inch of stroke will intersect, and at that point we control on 1G throughout the remainder of the test. We'll show you how that looks in the software. And then we have a sweep rate. So how fast am I sweeping from 5 Hertz to 1,000? That is 3 octaves per minute in this case. And then how many sweeps are we going to do in this test? It is 5. And for vibration view, this is one thing to keep in mind when you see a number of sweeps. What we do is we sweep from 5 to 1,000. That's one sweep. We'll continue. We'll go from 1,000 back to 5. That's 2. Next one up to 1,000 is 3. Back to 5 is 4. And we'll finish at 1,000. So if you have a test like this, you enter 5 sweeps, but the duration calculation is half. It's simply a matter of definition. The test profile defines a sweep as both directions, so up and down. I'll show you that in an example when we get into the software. So we will jump into vibration view and set up this sine test. So this is our simple test mode. You can see there are not a bunch of additional tabs on top here. If I hit advanced, you can see behind the curtain, essentially, you can see all the various tabs that we do have available. But for the first one, we'll stick in simple test. You'll notice it gives you all those required fields. So frequency, displacement, acceleration, sweep rate, duration. Didn't mention this, but what channel are we using for control? You do have the ability for a quick report and also sine resonance track dwell. At the end of the sweep, the dialog box will pop up. We have a great webinar on that if you'd like to check it out. That is also archived on the website. But for this profile, our frequencies were 5 to 2 kilohertz. And then we had the ability to limit displacement to 1/4 inch. Or 1G, whichever's less. And if you notice that preview graph above, what it did when I entered 1 is it added essentially a segment here. And this will be where we are controlling on displacement. If I click displacement here, you'll see that's holding steady until, we'll call it about 8 Hertz, something like that. And then at that point, we control on acceleration, and acceleration remains steady. Displacement will be decreasing as we increase the frequency. So that's what that step does. The next step was sweep rate. We said 3 octaves per minute, and then we said a total of 5 sweeps. So you'll notice down below we do give you the requirements, so system requirements to run this. Acceleration peak is 1G, velocity is about 7 inches per second, displacement is 1/4 inch. So with that is our example of a simple sine test. So very straightforward. We try to make it easy in simple test mode. You're not navigating through a bunch of various tabs. It's all right here in one easy to use dialog window. So I mentioned this is going to be a very, we'll call it brief overview of test entry. So try to show you a couple tips, tricks. If you have any questions, feel free to type those into the comments. I will answer them at the end. But with that, that is test number 1. So quick sign test. Going on, we have a little bit more advanced sign test. And in this case, we took this from Mill Standard 202G, test condition B. And we pulled the highlights out. You do have a real fun to read graph on the right-hand side here. It can be a little bit confusing, but we've broken it down and actually added words and descriptions on the left. So breaking this graph down, we have amplitude 0.06 inches peak to peak or 15G peak, whichever's less. So similar to our example on the last test. And then we have frequency range 10 hertz to 2 kilohertz. And then sweep time and duration. So the entire frequency range of 10 to 2 kilohertz and return, so up and down, shall be traversed in 20 minutes. That should trigger you based on our last test profile. It's saying up and down, so hopefully in your head you're saying, okay, that's 2 sweeps in the VR software. Shall be performed 12 times, a total of 4 hours per axis. But we will transition to the software here and enter this one. So back into the software, let's add a new test, Sine. And rather than doing this in simple test mode, I'll show you a quick example in advanced. So first step, profile, that's where you define the profile that we're going to run. And then we have 2 steps in this example. So let's just start. It says 10 hertz. And if we go back, its amplitude is 0.06 inches peak to peak or 15 Gs, whichever's less. If I put in 10 hertz at, whoops, didn't mean to do that, at 15 Gs, 15 Gs. So I have an unlimited shaker set up here. So I really don't have any limits, but if I look and I see 15 Gs at 10 hertz, I need a 3-inch shaker. And that's actually up at the limits of that 3-inch shaker. So not super common. I would assume it's going to be less here. So if I say, well, we know that, 0.06 inches. So we know that's less, so we say, all right, we'll start at 0.06 inches at 10 hertz. Continue to hold at 0.06 inches. But we know that next step was, or 15 Gs, whichever is less. So we say, well, what is the crossover frequency? I don't know. I'm just going to put in 100 here. And if I hit insert, so insert, let's change this to 15 Gs. I don't know that it's going to be at 100, but then I control on 15 Gs out to 2 kilohertz. So looking at this, you'll notice this top graph, it's not a smooth transition from displacement to acceleration control. We have a calc button that appears when that is true. And if I hit that calc button, what it says is, okay, 0.06 inches and 15 Gs, they intersect at 69.9276 hertz. Do you want it to intersect? I hit yes, and you'll notice that it makes that transition perfectly smooth, and that is always recommended. So you may see a test specification call for something like, they'll just say control on 0.06 to 70 hertz, and then at 70 go to 15 and control on 15 out to 2 kilohertz. We recommend using this calc tool. It's a rounding, I don't even want to say an error, but it's a rounding issue. That's why they round up to 70 to make it easier or appear a little bit more clean. But for that, so that gives us the actual profile. Now, what do we want to do with the profile? The next step was the entire frequency range at 10 to 2 kilohertz and return shall be traversed in 20 minutes. So, if we say here, I don't have written down if it specifies linear or log. I would assume log, so that's what we'll go for this example. But if you know one sweep is one direction, and they define the sweep as up and down in 20 minutes, sweeping up only will be 10. So 10 minutes up, 10 minutes down for a total of 20. And then it says the cycle shall be performed 12 times for a total of 4 hours per axis. So profile, I did sweep, how fast do I sweep? Schedule is how many times do I want to sweep. So I have sweep up from 10. My test said, okay, the entire cycle shall be performed 12 times. So if I put in 12 here, should be good, right? This is the gotcha. So we do have the timer based on what I input. 12 sweeps give me 2 hours. But the test spec says this should take 4. So I know, okay, it's a matter of definition. So I put in 24 sweeps. Sure enough, I have 4 hours for the entire test. You can get a little bit, we can make this a little bit more complicated on this step. It says it's for 3 axes, so I could do something like this to wait for operator, run it again, wait for operator. What this step does is it will complete this first 4-hour sweep, and then the test stops, a dialog box pops up. I can go rotate my product, rotate my shaker, whatever I need to do. Hit OK to continue. I'll run this sweep. Next one, wait for operator, box pops up. I have the ability to go rotate my product again, and then run the additional 4-hour test. So 3 axes, total of 12 hours. We're good to go. So you'll notice we are skipping over a lot of these tabs. We have in-depth webinars on each test mode that we offer. So if you want to go more in-depth and learn a little bit more about some of the additional capabilities, feel free to consult our website. They're all saved, all the past webinars that we do along with this one. They are saved on the website. It'll be archived webinars. Go knock yourself out, watch as many as you'd want or you'd like to. They are all free of charge. Okay, so again, any questions, feel free to check out the website, losing it here. Any questions, feel free to type them in the comments. I will get to them at the end of the webinar. So, next test mode. We've done Sine. We've done Advanced Sine. Little cheat sheet here showing the Calc tab. And next test is Random. So, Sine and Random, by far the 2 most popular test modes. This will be a quick example of a nav map profile. If you get a test spec, typically you'll see frequencies, amplitudes. Sometimes you'll see slopes if they don't define the lower amplitude or the upper amplitude. We can calculate those for you. But frequencies, amplitudes, we've got 20 hertz, 80, 350, 2000. And then they define the amplitude from 80 to 350 as 0.04 g squared per hertz. And then we have a slope. So 3 dB from 20 to 80, and then negative 3 dB from 350 to 2 kilohertz, and then we will calculate this amplitude. So, jumping back to the software, let's hit OK on this one. New test again, and random. This opens in simple test mode. You can enter it in either one. I'm just going to do advanced to show a couple of tips and tricks here. So when I know I have 4 breakpoints, I like to do 1, 2, 3, 4, and then just enter them, or you can enter one at a time, hit insert, add them one after the other. It's up to you. What I found is it's a little bit easier to do this way. So we've got 20. I can use the arrow keys to go down, 80, 350, and 2 kilohertz. And then my amplitude, I had the 80 hertz was 0.04. My 350 was 0.04. And then I have slopes defined. So if you take a look here, and we'll kind of isolate, so let's just delete 2. So you'll notice in between I have basically a triangle. I have these 3 breakpoints. And if I know this one, and I know this one, it'll calculate the one that's in yellow. So click-through rate is important in random. If you've ever got kind of sidetracked or buried in entering a profile, clicking around and you see boxes highlight yellow and that'll update, okay, I got to change that back. It can be a little bit frustrating. But the thing to know is, if you think of it as the triangle, if I know this one and I know this one, I enter a value in here and I tab out, it will update this amplitude here. So let's add our 4 again. I've got 20, 80, 350, 2 kilohertz. Next, 0.04, 0.04. And now let's say we want to calculate this value. I would click here. The slope was 3. Hit tab. That was already updated, so it didn't change, but it calculated that. Next, I would go click this field. So first click is a known. Second click is a known. And I tab out. That calculates that 2 kilohertz amplitude. And I have my profile. So 6.06, that is the check value. I've entered this one appropriately. One useful tool is copy and paste functionality. If I right click anywhere here in the empty space on this tab and I hit copy, I can go into Excel and paste it into here. And I can also go back the other way. So let's just say 1500 hertz just to show that it does work. Highlight, Control C for copy. Go back into my software, right click and hit paste. And we see that this value did update to 1500 hertz instead of 2 kilohertz. But we can do that and make random test entry as long as it's formatted in columns. Very, very easy. So eliminates mistakes. You can see this is 2, 4, 6 significant digits. If you've got a whole list of breakpoints, that can take quite a bit of time. So copy, paste. It is available. It's very effective and can make entering these profiles super easy. So I wasn't kidding. We're breezing through these. These are just, hey, how do I do a quick test entry? That was my random example. Again, we have a great webinar on our website that goes in depth on some of the advanced capabilities, control loop parameters, that type of thing. But that is not this webinar. So we're just going to keep moving on and get to shock here. So, quick example of a shock test. I would argue shock tests are usually pretty simple. You've got just a couple of parameters that you have to concern yourself with. Pulse width is a big one. So how long is it? 11 milliseconds in this case. Pulse shape or pulse type. Terminal peak for this example, you may be used to seeing like half sine. Sawtooth is another name for terminal peak. So I'll show you some of these in the software, show you how it looks. But pulse shape, pulse amplitude or peak amplitude, and then direction. So in this case, our example is 11 milliseconds, 50 Gs, half up, half down. Total is 6, so I'll have 3 positive pulses and also 3 negative pulses. So jumping back to the software, we have, let's get out of here, hit new test and shock. And our example was 11 milliseconds. Here's the pulse type, so half sine. Just watch this preview window up here. You'll see how the shape changes. Some test specifications call for sawtooth. We have, so terminal peak looks like a sawtooth. We also have initial peak, so it's a sawtooth in the other direction. So if you see sawtooth, just know we have both defined. Typically, it's going to be a terminal peak here. Peak amplitude, 50 Gs, so we got that entered already. And then we have pulse direction. You can do, so we said half up, half down. I can do half up, half down. That'll do 3 positive, then 3 negative. You could also do alternate up, down, so positive, negative, positive, negative. So we'll just do half up, half down. Total of 6. And then we do have the ability to add a delay in between pulses. So you run one, we'll wait a second before we output the next pulse. Typically useful to extend that if you have a product that rings down, so you shock it, and then the product kind of rings out. You want to wait till that product gets back to essentially non-ringing before you hit it with the next pulse. Control channel, good to go here. And then I will show the advanced test setup just because we have a couple of additional options that may be beneficial. So pulse shape here, 11 milliseconds, terminal peak, 50 Gs, entered that already. Schedule, so this is the part that I wanted to show. So we've got 3 pulses, 1 second interval, so I can change that if I want. We'll go through, we ramp up. So we start with a low output, raise the drive based on a gain parameter on one of the next tabs. Once we get to full level intolerance, we run 3 pulses. And then we're going to run negative pulses. That's what this checkbox is. And essentially what that does is it inverts the positive pulse and runs it in the negative direction. The memorized drive is the one that I don't see if I'm looking in simple test mode. It's just enabled by default. But that's saying, okay, I'm going to do some startup pulses when I'm running positive. So call it low level. You know, maybe one will be 5 Gs, 20 Gs, 35, and then we're at full level. Once I know the drive signal, a lot of times to run it negative, you can just say, okay, I'm going to just remember the drive that I used in the positive direction, invert it, and I don't have to have the startup pulses in the negative direction. So this is one that's easy enough to show. We'll just run this test. It's only going to take a couple of seconds. But the other options here, so open loop if you don't want to have any control, we're just outputting a voltage. You can do that. And then hold pulse is the other option. If you say, well, I don't know how long I want to have this pulse interval, I just want to hit run every time I output a pulse, that's what this does. So I'll show this one real quick. 3 positive, memorized drive, 3 negative, and then I did the hold, so I'll have to hit start every time. So hit run, you'll see the startup pulses. So low level, low level, low level. There we go, 1, 2, 3. Now we're inverting. So you'll notice the demand is now negative. And if I hit run, this will be a full level negative pulse. So none of those startup pulses. Okay, my product's ringing down. Yep, I'm ready for another one. There's pulse number 2. Okay, it's ringing down, it's ready to go. Run pulse number 3. So, any questions on that? Per usual, write them in the comment section. I will get to them at the end. Couple more to go. We've got some mixed mode tests. So here's the shock profile. Same thing we talked about. This is Sine on random. This is Mil Standard 810H, Category 9. We're not going to walk through calculating these frequencies in amplitudes. I just have a couple of images from the actual spec, more or less to show you how it can be a little bit complicated to calculate these. But Sine on random, in this case, this is to simulate a helicopter. So it's for a product that's going to be on a helicopter. You have to select the model number of the helicopter, and then you have a bunch of different parameters. I did MH6H, so my start was 7.8 hertz, but then you calculate all the subsequent tones. Amplitudes are up here, and then we have the random levels and frequencies. So this is a little bit complicated to work through. I've got one other screenshot, I believe. No, just this one. So we have here a bunch of variables. Here you determine what your knowns are and start from there and calculate them. And at the end, this is what we will run. So Sine on random is exactly as it I think as you would think when you hear the name. We're running a random test with various sine tones superimposed on top of the random. Those sine tones can sweep or be stationary. In this case, these are just sine dwells. So I've got random, my breakpoints, it's 4 breakpoints long. And I might make this easy here. I'll just copy those. And then I have 4 sine tones, and they're fixed. 7.8 hertz, 39 hertz, 78 hertz, and 117 hertz. And then the amplitudes are 4.1, 2.5, 1.5, 1.5. So I did a lot of the work calculating these. We'll just go through and enter it and show you how you would do that. So new test, Sine on random. And this is exactly as we did in the individual test mode. So this is random. I didn't like it out of there. So I'll manually enter this. I'm going to do 4 breakpoints. It was 10, 100, 300, 500. And then my amplitudes were 0.001, whoops, 0.01. I'll just do it that way. And then 0.001. So that is my breakpoint table. This does look identical to the random setup, but you have a couple of additional tabs here. So we have a Sine on random parameter tab, tracking filter settings, slew rate, response time, and then like limits, that type of thing. But where you actually enter the tones is SOR. And I have 1, 2, 3, 4. We're just doing the hold at. You can sweep. So if you want to sweep up or sweep down, you select those here. But frequencies, we'll do 7.8, 39, 78, and 117. And then we have the amplitudes, 4.1, 2.5, 78, and 117. So 4.1, good deal. And then we have right here, so I can see this is one sine tone, this is one, this is one, this is one. Looking at it here, you can see the actual profile. And then schedule tab, by default, we just turn it on. So I would run for 1 hour, I would have these fixed sine tones, and we would run for, in this case, it actually said 12 hours in my spec, so 12 hours. If you want to hit insert, some people will have the random come up to level and then turn on the sine on random tones. It's just adding an additional schedule level, turning it on or off. So table for the random, sine on random for the sine tones, go from there. So hit OK and we are ready to run. Beautiful. All right, so next one is random on random. So instead of having those sine tones superimposed, we've got random, background random, and then we have narrowband random on top. In this case, I defined my random on random, so it's 12 minutes. Okay, so sweeps one sweep basically, so it'll be low to high. Broadband random, 5 hertz to 500, 0.0043 G squared per hertz. And then these will be our random on random bands. So let's go through 5 to 500 at 0.0043. So what did we say? 5 to 500 at 0.0043. If we tab out, we know it's a flat spectrum there. So 5 to 500, 0.0043, just like we've done in the other random examples. To enter these random bands, we have ROR, so random on random tab. And then I had 1, 2, 3, 4, 5. 4, 5. So these were our random narrow bands, and it's a little bit different with the definition. So basically what we have is a frequency range. So this range is from 30 to 35 hertz at a given amplitude. But then we have a bandwidth, so 2 hertz wide. So we'll start at 30 to 32 hertz, and then that 2 hertz bandwidth will sweep from 30 to 35 hertz. And the spec I think we said was 12 minutes. So if we go back into the software, let's enter these. I'm going to change, these are all the sweep rates, so I'm going to change all of them. We said minutes per sweep linear, minutes per sweep linear. So I'll just change them all right now. And then we said 12, so 12 minutes per sweep, 12, 12, 12. Good. So what was the frequency range for each of them? My first was 30 to 35. 30 to 35. Amplitude was 0.06554. And my bandwidth was 2 hertz, so that's my first tone. Second one, 60 to 70. Amplitude 0.02995 with a 4 hertz bandwidth. Just continue on, enter the rest of these, 90 to 105 at, 0.02358. Bandwidth is 6. This one was 120 to 140 at 0.00522 with an 8 hertz bandwidth, and 150 to 175 0.0067 at 10 hertz. And then we did have a, let's see, so 1.46. Yeah, and then 1.0461 G's RMS. So random on random, let's take a peek here. We don't need these steps. This is the preview window, so we can see 1, 2, 3, 4, 5 distinct tones. This one's not super high in amplitude, either is this one, but 1, 2, 3, 4. Run for, what was the duration on that one? 12 minutes. So 12 minutes. So random comes on, these tones will sweep their range. One sweep will take 10 minutes. Test is done. All right, so questions, again, feel free to enter them. We are up to our last test mode, and that one is going to be FDR, or field data replication. Might be a little less common, so just a real quick overview. This is, I have a time history file and I want to replicate it one-to-one on a shaker. So I went out into the field, I collected field data. I want to replay that field data file on my shaker system on a sample by sample basis. So exact replication of a of a time history file. Easiest way to explain this is going to be with a song, and I'll show you that here in just a second. But we can take in a bunch of various file formats. We've got CSV, text, RSP, whoops, this should be RPC. Looks like we just duplicated it here. UFF, WAV, Universal, VFW, that's our proprietary format. But a lot of different files we can bring in. And then we convert them to VFW and replay them on the shaker system. So I mentioned a song is the easiest way to show this capability. I took a song, converted it to a VFW file, and we can replay it on a shaker system. A shaker is essentially a big, poor quality, speaker. So a lot of people do this for take your kid to work day or an open house, something like that. You can take a song and you can actually replay a song on a shaker. So if anybody has an event like that coming up, feel free to reach out. We're happy to help with converting songs, MP3s, whatever, and getting them to you in a format that you can replay. And we can also give you a temporary key for our field data replication software. But cool way to show, hey, what is a shaker system? What does it actually do? And that's obviously in addition to the useful testing application of replaying real-time histories. But I'll show you how this process works. So new test, FDR, I did that. We go in, and then I've got a couple of files. And if you saw by the name, you should be able to hear this in just a minute. But we bring it in, give you the sample rate, how long's the file, what's the max, so G peak, what's the RMS, velocity, displacement. If you see any reds here, that means you are exceeding your system limits. If you see a yellow, you're within 90 to 99% of your shaker capability. Can run it, but I'd probably dial it back a little bit. On the schedule tab, you could say, okay, I want to run this at 50%, something like that, so it's well within the limits. But with that, I have a file that I'm going to play. Wonder if we can get the system. Yeah. I hit start, and we come up to level and we start playing through that file. This is a new feature in this version of software. You can now see the entire time history on the bottom, along with a progress bar. So where are we in that time history? But with that, that is a crash course in test entry in vibration view. So sine, random, shock, sine on random, random on random, field data replication. Hopefully showed everyone at least a thing or two that they didn't know before. If you have any questions, I'll stick around for a few minutes here. Feel free to type them in the comment box below. And if you have any questions, we've got the support email and contact info here. Feel free to reach out to vrsales@vibrationresearch.com or support@vibrationresearch.com. And I appreciate your time. Look forward to speaking with you soon. Thanks.